Okay, so I just wanted to make a video going over some of the problems on your exam and kind of working through them. For those of you who wanted to see a score key or something, I'm going to scan the score key in, but I figured here you can see me working through some of the problems. I'm not going to do all of them, but I'm going to go through a bunch of them as fast as we can. First off, the first four problems were essentially solving triangles out. So just to pick one at random, 3A says determine the number of solutions to the oblique triangle, do not solve. Some of you solved them on your exam or whatever. It didn't matter, I just needed to know the number of solutions. But we're told A equals 29 degrees, lowercase a equals 7, lowercase b equals 10. Which means if I draw a triangle, we'll call this A, so it's 29 degrees. We'll say this is B and that's C. Then side B is 10, side A is 7, and side C, we don't know, it's over here. We want to solve this out. And the method of solution is the same for all of them. In this case, well, I know this angle and this side, and I know this side, and I'm looking for that angle. So I can apply the law of sines. Law of sines says sine of 29 degrees over 7 equals sine of B over 10. And now just solve for B. Multiply the 10 over, you get 10 sine 29 over 7 equals sine B. So throw that into your calculator. 10 sine 29 divided by 7, and I hit the wrong button on my calculator. 10 sine 29 divided by 7 equals 0.6925. So sine B equals 0.6925 roughly. And now we just do sine inverse. Second sine inverse, and we get 43.8. So B equals 43.8 degrees. But then the one trick to this is, there's the potential that we might get two triangles here, so we always have to check this. And all you do is, we know from unit circles, if this is my unit circle right here, this angle, 43.8 degrees, gives me that sine value. But this angle also gives me that sine value. So I have to check that angle to see if it works on my triangle. If this is 43.8, then I can check what the other angle is by doing 180 minus 43.8, which is 136.2. We know this angle will work. There's the potential this one will. To see if it works, we just check it. If B is equal to 136.2, we know A is 29, then we just check and see if that will give me a triangle. If it's possible, 136.2 plus 29 equals 165.2, which would mean that's still less than 180, so there's the potential for there to be a C, roughly 15 degrees, which means we can get all three angles of a triangle, so that one works. So then essentially I get two triangles. The first one has angle B equal to 43.8. The second one has angle B equal to 136.2. Now I just need to find angle C and side C for both of them. I'm not going to go through the math for both of these, but essentially, if angle B is 43.8, angle A is 29, we add those up, and then we subtract from 180 to get the third angle, which is 107.2. If 136.2 is angle B, do the same thing. 136.2 plus 29, and then subtract that from 180, I get 14.8. Now to find side C, well, we do the law of sines just like we did to find B. We do the law of sines to find side C. We just have to do it twice. Once with this triangle, once with that triangle. I'm not going to do that again just to save time. All of you know how the law of sines works. Okay, next up, let's see. What should we go over? Okay, convert the following point from polar to rectangular. So suppose we have the point 4 pi over 3. First thing we always do, graph it. Radius of 4, angle of 4 pi over 3. That means I'm down here. 4 pi over 3 is 240 degrees. So I'm right down here. And my radius is 4 right there. Now I just want to convert that to rectangular coordinates. But, well, I can just draw a triangle. We know if this is 240 degrees, this angle right here on the triangle is 60. We know this is equal to 4 because it's the radius. Now to find the rectangular coordinate, I just need to find x and y. But I can just use my trig functions for that. Let's see, I can just say sine of 60 degrees is equal to opposite, which is y, over hypotenuse 4. So y equals 4 sine 60. Sine of 60 degrees is root 3 over 2. So we get 4 times root 3 over 2. 4 and 2 cancel, and we get 2 root 3. The only thing to keep in mind here, that's the side, the y side, the vertical side of the triangle, but now we have to remember quadrants. We're in the third quadrant. In the third quadrant, y is negative, so I just stick a negative right there. Now do the same for x. Let's see. Cosine 60 degrees equals x over 4. So 4 cosine 60 equals x. Cosine of 60 is a half, so we get 4 times a half, which is 2, and that's my x. And then again, in this case, we're in the third quadrant. X values are negative there, so it's negative 2. And now I have my point. Negative 2 root 3, x and y. And I'm done. The next problem on your exam said convert this point to polar coordinates. I'm not going to take the time to do that because you literally do the exact same thing backwards. If you plot the point, which is right here, and you know that the x value is negative 2, the y value is negative 2 root 3, you can get the radius, just do the Pythagorean theorem, and you can get the angle, just do tan inverse, and you're done. So I'm not going to take the time to solve that one out. You get the exact same point in polar coordinates as we got right here. We're just going back and forth. Next up, and I have to keep checking the time to make sure this doesn't run over. Let's see. Convert equations from polar to rectangular. For the most part, people have been well on these, so I'm only going to check 1 or 2 of them. So, if we have r equals 3 sine theta, we need to convert that. The r we can convert. We remember our conversions. R squared equals x squared plus y squared. Y equals r sine theta. X equals r cosine theta. I can actually convert r, I just square root both sides, and r is the square root of x squared plus y squared. The problem is, I can't convert sine theta by itself. The only conversion I have is r sine theta. So I can do something algebraically. I multiply both sides by r. Then I get r times r squared equals 3r sine theta. Now I can convert. R squared now is x squared plus y squared equals 3r sine theta is y. And there we go. We converted it. You can manipulate that algebraically and write it in different forms, but for the purposes of this, that's fine. Next up. Suppose I'm in a boat and I travel at the bearing north 80 degrees east at 20 knots for 2 hours. So we draw a picture. My bearing is north 80 degrees east. So that's north 80 degrees east means I'm right down here. This angle is 80 degrees. I do that at 20 knots for 2 hours, which means this is length 40. Then I turn 90 degrees clockwise and travel for 4 hours at the same speed, which means I turn down here. I turn 90 degrees clockwise, so I look like that. Travel for 4 hours at the same speed, which is 20 knots per hour for 4 hours, so that's 80 on this side. Then I'm told to find my distance from the dock where I started and find my bearing relative to the dock. So first off, my distance to the dock is that distance right there. But this is just a right triangle right there since I turned 90 degrees, which means to get this, Pythagorean theorem. 80 squared plus 40 squared equals c squared. Throw it into your calculator and you get c equals 89.4. So my distance to the dock is 89.4. Now I just need to figure out my bearing relative to the dock. And here we just have to be careful. My bearing relative to the dock, we know bearing is related to north and south. So my bearing is this angle right here. And how do I go about finding it? Well, I know this is 80 degrees. This angle right in here is part of the triangle. If I can find that angle in the triangle, the whole straight line measures 180. So I can add these two angles together and subtract from 180 to get that. So now I just need to find this angle. But, well, let's see. This is a right triangle. I can just use my trig. I'm going to use the two values I'm given. So we're going to call this angle theta. We have an opposite and adjacent. So we'll say tan theta equals opposite 80 over adjacent 40, which is equal to 2. Now just do tan inverse. And if you do tan inverse, you get 63.5. Now, if this is 80 and that's 63.5, I can add those together. 143.5. But all three angles together add to 180, so just subtract that from 180. 180 minus 143.5. 10 minus 5 is 5, 9 minus 3 is 6, 7 minus 4 is 3. We get 36.5. So this angle is 36.5. And then my bearing is north. I'm sorry, south. I'm going down. So it's south 36.5 degrees east. And I'm done. As I stressed when we did these before, biggest issue, make sure you draw a picture. It helps a lot in determining what's actually going on. We're going to be doing more bearing problems as you've seen in your homework. So just always draw a picture to get an idea of what's going on. And let's see. I have about 2 minutes left. I'm going to end this video right here and start another one to go over the last few problems on your exam.